This is the Unit 2 review key video. First thing you have to do is convert these degrees into radians. To do that, we're going to multiply by pi over 180. So we get 365 divided by 180. We get a decimal. We convert that to a fraction. So we get 73 pi over 36. Actually, we're going to go down here, make it a little bit easier to go across. For number 4 here, we have, again, we're multiplying by pi over 180. So we have 370 divided by 180. We change that decimal to a fraction. We get a weird video. There we go. And we have 37 pi over 18. All right, the next two. Again, pi over 180. So negative 8 divided by 180. Convert to our fraction. We get negative 2 pi over 45. Same thing. That's an 8. So you have negative 12 divided by 180. Our fraction. Negative pi over 15. Moving on, the last two here. Again, multiply by pi over 180. 75 divided by 180. Change your decimal to a fraction. You get 5 pi over 12. And the last one. So 25 divided by 2. We're going to divide that by 180. And we get our fraction, which is going to be 5 pi over 72. Okay. There's degrees to radians. Now we're going to go from radians to degrees. So you're going to flip your conversion upside down. So now we're going to multiply by 180 over pi. So we have 1 over 5 times 180. Gives us 36 degrees. Here, 180 over pi. So 1 over 9 times 180. This is 20 degrees. Next two. Our conversion gives us 140. So 7 divided by 5 times 180 gives you 252. Last two. By 180 over pi. 6 times, times 180 gives you 1080 degrees. And finally, 13 pi times 1 over pi. 13 times 180 gives you 2,340 degrees. And there we go. Next, I'm going to find a radian measure of something between 0 and 2 pi. Okay, that's coterminal with what we're given. So the first thing we have is negative 15 over 2. So that's too small because it's less than 0. So negative 15 over 2. We're going to add 2 to that until we get it to be above 0. And now it's above 0. So I found out it's decimal equivalent, I keep getting these adds. And it's equivalent, so it's pi over 2. We just added 2 multiple times. Next, 31 over 6. We can see that is bigger than 2. So now we're going to subtract 2 until we get a number between 0 and 2. Now that's between 0 and 2. Turn our decimal into a fraction. 7 pi over 6 is our coterminal radian. And lastly, 14 divided by 3 and bigger than 2, so we subtract 2 multiple times. We get 2 pi over 3. There are our values. All right, next. We have to find, for these problems, the point that's given to us on the unit circle, and then multiply the points together. So the first one is cosine of 2 pi over 3. You're going to need your unit circle for this. So you find 2 pi over 3 in a unit circle. You find the x value. It's negative 1/2. Then we find 11 pi over 6 on the unit circle and find the sine value, which is the y term. And it's again negative 1/2. Now we're just going to multiply these things together. So negative times a negative is positive. 1 times 1 is 1. 2 times 2 is 4. You get 1 over 4. Okay. Next, tangent of 5 pi over 4. So again, you have to find your unit circle. 5 pi over 4. Find the 2 points. So we're going to have 5 pi over 4. You have negative root 2 over 2 divided by negative root 2 over 2. That just gives you positive 1. That's it. Then sine of pi over 2 is the y value, which is just 1. So we have 1 times 1, which is just 1. Okay. Now this one's a little bit trickier because this one has sine of pi over 3. Well, pi over 3, it has sine of negative pi over 3. And negative pi over 3 is not on our unit circle. It is too small. So what we have to do is find its coterminal on the unit circle. So what we do is we take in negative 1/3 divided by 3. And then we add 2 to it. And we find out what its coterminal is. So it's 5 pi over 3. So this is actually sine of 5 pi over 3. Okay? With that known, we can then look at our unit circle again and look at what 5 pi over 3 is for the sine. So 5 pi over 3, its sine is going to be negative root 3 over 2. And then cosine of 4 pi over 3, looking at a unit circle, cosine of 4 pi over 3 is negative 1/2. So negative times a negative is a positive. Root 3 times root 1, root 3 times 1 is root 3, and 2 times 2 is 4. And that's your answer. Okay? All right, next. So sine of 5 pi over 3, we'll get 5 pi over 3 on a unit circle. The sine of that is going to be the y value, so it's negative root 3 over 2. And the tangent of 2 pi over 3. So tangent of 2 pi over 3 is sine divided by cosine. So we have root 3 over 2 divided by negative 1/2. Now for this one, we have to multiply by the negative 1/2, actually by the reciprocal, so it'll be negative 2 over 1. My apologies, negative 2 over 1 on the top and the bottom. Let's make this times negative. There we go. All the stuff on the bottom is designed to cancel out. The 2's will cancel, and we'll be left with negative root 3. And that's it. Everything else is good. Number 20. Cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. Tangent of pi over 6 is 1/2 divided by root 3 over 2. So multiply this by, actually no we don't. So this is a little bit of a trick question because you're multiplying whatever is on the right hand side with the tangent by 0. So this is just going to be 0 because anything times 0 is 0. So we don't actually have to figure out tangent of pi over 6 because it's irrelevant. All right, tangent of 5 pi over 4. Look at our unit circle. We find that it is negative root 2 over 2 divided by negative root 2 over 2 is just positive 1. And 7 pi over 6 is going to be the sine, which is the y term, which is negative 1/2. So we're multiplying 1 times negative 1/2, which gives us negative 1/2. That's it. So all those answers can basically be found with the unit circle and then some basic multiplication. All right. Finding some points. Okay, so we got to find these points and then find the sine, cosine, and tangent of this. So we're first going to draw a little picture. Negative 5 goes this way. 12 goes this way. And our hypotenuse is there. This is our angle. So we need to find the hypotenuse of our triangle. So we do 5 squared plus 12 squared equals that. We take the square root of that answer. You get 13. So the sine is the opposite over the hypotenuse. Opposite is 12 over 13. The cosine is the adjacent over the hypotenuse, which is negative 5 over 13. The tangent is opposite over adjacent, which is negative 12 over 5. And that's it. Next, draw another picture. We have 8 going this way. Actually, I'm going to put that on up here. We have negative 1 going that way. The y value, our theta is right there. To find our hypotenuse, we do 8 squared plus 1 squared, which gives us 65. So this is going to be the square root of 65. So our sine is going to be the opposite over the hypotenuse. So the sine is going to be negative 1 divided by the square root of 65. Now we can't leave the square root of 65 on the bottom of our fraction. So we're going to multiply it to the top. So we will get negative root 65 over 65. For the cosine, adjacent over hypotenuse is going to be 8 over the square root of 65. Like before, we can't leave 65 on the bottom of our fraction. So we're going to multiply it to the top. So we will get 8 root 65 over 65. And finally, opposite over adjacent is going to be negative 1 over 8. 24. Here we go. Draw our picture. We have negative 7. And we have positive 13. So we're going to find the hypotenuse. We have 13 squared plus 7 squared. Gives you 218. And that's not a perfect square. So we're going to leave it as the square root of 218. So the sine is going to be, again, the reference angle is by the origin. The sine is going to be 13 over the square root of 218. Like before in the last problem, we can't leave the square root at the bottom of our fraction, so we multiply it to the top. So we have 13 square root of 218 divided by 218. The next one, the adjacent on the hypotenuse, we have negative 7 over square root of 218. Multiply that to the top. So we have negative 7 square root of 218 over 218. And finally, tangent is opposite over adjacent. Negative 13 divided by 7. Last one. So this, we have 6. And we have 1. There's our reference angle. So 6 squared plus 1 squared is equal to 37. So we're going to leave that as the square root of 37. So the sine is opposite over hypotenuse. So we have 1 divided by the square root of 37. Multiply that to the top. So we get square root of 37 divided by 37. For the cosine, adjacent over hypotenuse, 6 over root 37. So we have 6 root 37 over 37. Lastly, the tangent, opposite over adjacent. is 1 over 6. All right, there we go. All right, now in these problems, what we have to do is kind of like what we did up here in 13 through 15. Got to find coterminals, but this time we also have to find what their sine, cosine, tangent is. Okay, start off with 13 over 6. It's too big because it's greater than 2, so we're going to subtract 2 from that. And then convert that to a fraction. Again, getting a nice Walmart ad right here. So I'm going to get pi over 6. Now I consult my unit circle at pi over 6. The sine is 1/2. The cosine is root 3 over 2 because it's the x term. The tangent is those two things divided by each other. I'm going to multiply by the reciprocal of the denominator. All that stuff on the bottom will go away. 2's will cancel out. I'll get 1 over root 3. But just like our last problems, we can't keep that root 3 on the bottom. We're going to multiply it to the top to get us root 3 over 3. Next, negative 19. That's too small because it's a negative. So we're going to add 2 a couple times to get us, one more time, a positive number. Gives us 5 pi over 3. I need to put there 5 pi over 3. Looking at 5 pi over 3, I have negative root 3 over 2. I have 1/2. And the tangent is going to be negative root 3 over 2 divided by 1/2. Multiply by the reciprocal of the denominator to get it off there. All this stuff cancels. The 2's cancel. I'm left with negative root 3. Next one, 9 over 2. I'm going to subtract 2 a couple times. I get pi over 2. So, looking at pi over 2, the sine is 1, the cosine is 0, and the tangent is 1 divided by 0, which is undefined. So we just write down undefined, because you cannot divide by 0. All right, next couple. Did I have the same? No, I don't. Okay, that was a repeat question. So you got 19 over 6. Subtract 2. That's 7 pi over 6. So looking at 7 pi over 6, our sine is negative 1/2. Our cosine is negative root 3 over 2. Now, we've already done one of these just like this, which is the one right above it. So we have 1/2 and divided by root 3 over 2. So I don't need to go back and redo the math part. It's going to be, since both those terms are negative, it's going to be a positive root 3 over 3. A negative divided by a negative is a positive. We've already done 1/2 divided by root 3 over 2 up here in question 26. I know that's what it's going to be, so I don't have to show the work again because I've already done it. Number 30. So negative 7 divided by 3. To add 2. Add 2 again. I'm going to get 5 pi over 3 and a beautiful something new. I don't know what that was. Another commercial. So sine of 5 pi over 3. Where's 5 pi over 3? There it is. So the sine is going to be negative root 3 over 2. The cosine is positive 1/2. Now again, I just did this problem above. So I have the same radian. I don't need to do it again to divide them because I've already done it once. It's just going to be negative root 3. So anything with a denominator of 6 is always going to be root 3 over 3 and either positive or negative depending on where the point is. Anything with a 3 in the denominator, it's going to be root 3, either positive or negative depending on where the point is. Okay, last one, 13 over 2. Way bigger, so I have to subtract 2 a couple times. Get 0.5, which is going to be 1/2. So I have pi over 2. And I did the same thing above there. So it's 1, 0, and undefined. So once you've figured out what the coterminal angle is, or the radian, for these problems, it's just a matter of looking at the unit circle to find out what the point is, and then dividing sine and cosine appropriately. All right, now we get to our favorite problems. Oh, look at how many there are. It's so beautiful. All right. Now, for these problems, if you're trying these out on your own, which you should be, and you get a different process, that's fine, as long as you get to the correct right answer and the work is correct. You didn't break any math rules. I'm going to show you how I would do them. If you have a better way or a different way that works good for you, feel free to use it, as long as, again, it doesn't break any math rules and I can follow your logic. All right, cosecant is also 1 over sine, or 1 over secant, or secant is 1 over cosine. I multiply by the reciprocal of this. All these will cancel. This will give me cosine x over sine of x, and that would be cotangent, based on our quotient identities. Okay, I don't care about the answer so much, I care about all the work. Next, secant is also 1 over cosine. Cotangent is cosine over sine. All right, these two cosines will cancel, leaving me with 1 over sine. And 1 over sine is cosecant. All right. Some Pythagorean identities. So 1 minus cosine squared is sine squared. And then cosecant squared is 1 over sine squared. So we can put this over 1, and if we want, we can put that in parentheses. Oh, excuse me. Now we can cancel the signs out, which is only left us with 1, which is what we're looking for. All right. Next, we have 1 plus tangent squared. So this is, again, a Pythagorean identity. All right, so we got to look at our unit circle. All right, which this is one is, I don't have my unit circle in front of me. Give me 1 second. There it is. It would be secant squared. Sorry about that. All right. And then I'm going to multiply that by sine squared. All right. Secant squared is also 1 over cosine squared times sine squared. Since that's over 1, I get sine squared over cosine squared, which gives me tangent squared. Alrighty. Okay, so in this one, I'm going to leave, I'll blow this up a little bit. I don't need the calculator anymore. Get rid of that. Of course, hang on. Sorry about that. My pen decided to die. There we go. So I'm going to leave the top of sine times cosine alone for right now, and I'm going to do the bottom. So I have to multiply these two sets of parentheses together. If I do, 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine. And cosine times negative cosine is negative cosine squared. Okay. these two will cancel each other out because one's positive, one is negative, and I'm left with sine cosine over 1 minus cosine. Okay. Now, the bottom is a trig identity, or sorry, a Pythagorean identity. So I will get sine and cosine of x over sine squared of x. Okay. Now I have one sine on the top and two sines on the bottom, so I'm going to get rid of that one. So I'm left with cosine over sine, which leaves me cotangent equaling cotangent. Okay. All right. This one is a little tricky. All right, so I have two terms here in this problem. Here's the first one. This is the second one, and they're being subtracted. Well, in my two terms, I have something in common for both of those terms. I have tangent squared. I'm going to take that out as a greatest common factor, and I'm left with 1 minus sine squared. 1 minus sine squared is also cosine squared. I still have tangent squared, which I'm going to make the tangent squared into sine squared over cosine squared. When I do that, these two cosines will be canceled out, and I'll be left with sine squared equals sine squared. All right, in this one, we're going to convert everything in terms of sine and cosine. So cosecant is 1 over sine minus cosine. I'm going to put that as a fraction for now over 1, just because I have a feeling I'm going to need it later. Cotangent is cosine over sine. Okay, now I'm going to multiply the two fractions on the right. I have 1 over sine of x, still stays the way it is. The cosine times cosine becomes cosine squared of x, and 1 times sine is sine of x. So what I have now is two fractions that have a common denominator. I can combine them together to give me 1 minus cosine squared over sine of x. Excuse me. 1 minus cosine squared is a Pythagorean identity. It is sine squared over sine. So I can cancel out one of these sines with 1 on the top, and I'm left with sine of x equals sine of x. All right. So like before, I'm going to turn all this stuff into terms of sine and cosine. So this is sine over cosine plus cosine over sine. Now these do not have a common denominator, so we need to make one. So our first fraction has a denominator of cosine. What it's missing is the sine from the bottom of the other fraction. So I'm going to multiply this side by sine of x on the top and the bottom. On the right-hand fraction, though, it's got the sine. It's missing the cosine, so I'm going to multiply by cosine of x on the top and the bottom. Okay, when I do that, on the top of the first fraction, I'll have sine squared of x over sine x cosine x. On the second fraction, cosine times cosine is cosine squared over sine cosine. Now that I have a fraction with a common denominator, I can combine them. Sine squared x plus cosine squared x over one denominator of sine x cosine x. The top now is a Pythagorean identity. So sine squared plus cosine squared is just 1 over sine of x cosine of x. And then this, 1 over sine is cosecant, and 1 over cosine is secant. And that's just what we were looking at before. Now, this on the answer for the verifying is backwards. What I got, they're interchangeable. Since you're multiplying, it doesn't make a difference which one goes first. But I will switch them around just to be consistent. That was an equal sign. And there is your answer. Again, I'm not so concerned with the answer as I am with the work of how you got to that answer. All right. Again, I'm going to make these into terms of sine and cosine. This is going to stay as cosine. Oh, there's a theta. I want to put that over 1 because I feel like I'm dealing with fractions. Tangent is going to be sine over cosine. And then times sine theta over 1. Okay? I feel like I've seen this something like this before. I'm going to multiply the two fractions on the right-hand side. So I'll be leaving the cosine over 1 as it is. The two sines on the top give me sine squared over a cosine. Now, in order to combine these two fractions, I need to have a common denominator. I'm missing a cosine. So I will get cosine squared on the top, cosine on the bottom, plus sine squared on the top, and cosine on the bottom. Now that I have a common denominator, I'm going to get cosine squared plus sine squared over cosine. Again, the cosine squared plus sine squared is a Pythagorean identity, so it gives you 1 over cosine, which gives you secant, which is what we were trying to get. There we go. Again, we're going to use fractions, change all these things into sine and cosine, so that's going to give you 1 over cosine minus sine. I'm going to put that as a fraction, and sine over cosine. Okay, I'm going to leave the 1 over cosine alone. I'm going to multiply the two fractions on the right-hand side together, so I'm going to get sine squared over cosine. My two fractions now have common denominators, so I have 1 minus sine squared on the top over 1 cosine on the bottom. 1 minus sine squared is a Pythagorean identity. Gives me cosine squared over cosine. I cancel out one of the cosines on the top and the 1 cosine on the bottom, which gives me cosine. And there we go. All right. Continuing on. So for this, tangent is going to be sine over cosine. Sine is going to be sine over 1. They're being multiplied. On the bottom, I have secant squared minus 1. Secant squared minus 1 is going to be tangent squared. Okay, what I'm going to do next, I'm going to multiply my fractions on the top. Sine times sine is sine squared. Cosine times 1 is cosine. Now on the bottom, my tangent squared is going to become sine squared over cosine squared. Now I'm going to multiply by the reciprocal of the denominator, or the bottom fraction, so I can get it off the bottom and bring it to the top. It's designed to cancel all this stuff out, which it does. The sine squareds on the top cancel, the cosine on the bottom cancels there, and one of the cosines there cancels out, and I'm left just with cosine. So here we have cosine. Tangent is sine over cosine. And 1 over cosecant is 1 over sine. I'm going to put the cosine on the front over 1 just so we can see everything. The cosines will cancel, the sines will cancel. We'll be left with just 1 equals 1. All right, here. So Now, this isn't going to break any rules. I know that cosine and secant are reciprocals of each other. So if I multiply those two things together and I distribute the cosine into the parentheses like this, cosine times secant is going to cancel itself out, so it's going to give you 1. And cosine times cosine gives you negative cosine squared. That would be acceptable because you should know that cosine and secant are reciprocals of each other. When they're multiplied together, they would cancel each other out. And then 1 minus cosine is a Pythagorean identity, which gives you sine squared. If you did that on the test, as long as you showed that you're, the next step, that would be okay for me. Just so you know. Next one. So tangent is sine over cosine. Yep. And then cosine squared stays on the top. It's over 1. This cosine cancels with one of those cosines, and we're left with sine times cosine, which is what we got on the verifying part. That was an easy one. All right. For this one, 1 plus tangent squared is a trig identity. A Pythagorean identity. I keep saying that. 1 plus tangent squared is secant squared times cosine squared. Well, cosine squared will stay. Secant squared becomes 1 over cosine squared. And then those two things would cancel to give you 1. Next. Cosecant minus cotangent. Well, that's a Pythagorean identity. So the work is done for you. You just have to rearrange the identity, which I don't need to see. That's kind of not the best question. 4 to go. Sine will stay the same. Cotangent will become cosine over sine. And the two sines cancel off to give you cosine is equal to cosine. There's a big plane overhead. Secant is 1 over cosine minus cosine over 1. Now here we have two fractions. You cannot cross out the two cosines because there's a minus sign between the two of them. If there was a multiply, you'd be able to do that, but you can't for this one. So we have to find a common denominator. The common denominator would be cosine. So I'm going to multiply this by cosine, the right-hand side. So we get 1 minus cosine squared over cosine. The 1 minus cosine squared is a Pythagorean identity. So it's going to give you sine squared over cosine. Now this is where the verifying ones come in handy. I know I've got to get tangent times sine. So what that means is I have sine times sine on the top over a cosine. These two become tangent times the sine that was left over. And that equals tangent sine. Okay, this is the case where understanding that these are verifying and you know where you're supposed to end up, that tells you what else you might have to do to get to the simple part of, or the simplification that we're looking for. Here, we have cosecant minus sine, so we have 1 over sine minus sine over 1. This probably is a lot like the problem we just did. We're going to multiply by sine on the top and the bottom. So I get 1 minus sine squared. On the top, on the bottom I just get sine. The 1 minus sine squared becomes to cosine squared as a Pythagorean identity over sine. And then because I know this is verifying and I have to get cosine times cotangent, I'm going to break up the cosines. Divide this one by sine. So I get cosine times cotangent. Last one. So this, we've seen this problem before in the homeworks. I'm sure we've probably seen all these problems on the homeworks or the practices. This squared means I'm going to be multiplying 1 plus sine times itself. Okay, so 1 times 1 is 1. 1 times sine is sine. Sine times 1 is also sine. And sine times sine is sine squared. The two terms in the middle here are both positive signs, so I'd have 1 plus 2 sine plus sine squared, which is what I was trying to get. And that is the review sheet. All right, hopefully you study well and do well on the test. Good luck.